let me start now. Okay, so if you end up at this point on this problem with it saying something like 5 equals 8, that means no solution because it's not a true statement. If you ended up with a true statement like 5 equals 5, then that means it has infinitely many solutions. Okay, so that's what we're looking for. We're looking for, number one, does the u go away? If it doesn't, then I just solve it like normal. But if it does, then it's one of those other two categories. So to start with, we would distribute your 5. So this is 10 minus 5u minus u equals, and then we'll distribute the 2u plus 2. I have negative 5u and negative u, so that's negative 6u. And then I have 2u plus 2. I need all the u's on one side, and I need all the numbers on one side. So I'm going to add the u's to the right, just because then I have a positive u value. And at the same time, just because I'm trying to save a little bit of space, I'm going to subtract my 2 from both sides to move it to the left. So of course this adds to 0 and this adds to 0, which is the point. I have 8 on the left and I have 8u on the right. So in fact the u's did not go away, and I have u equal to 1. So there's one solution. It's that second option where it says u equal to 1. On part B, that equation starts out 4 times w plus 1 minus w equals 3 times w minus 1 plus 7. Okay, so just like on the other one, we've got some distribution to start with. So I have 4w plus 4 minus w equals 3w minus 3 plus 7. So on the left I have 3w plus 4, and then on the right I have 3w plus 4. Okay, so what do you notice happened at this point? They're exactly the same. If I tried to move the w's, like if I tried to subtract them, say, oh, I'm going to move the w's to the left, to the right, whatever you think, they're going to go away. And I'm not going to be left with anything that's got w's still in it. I'm only going to be left with numbers, and the number statement that I'm left with is a true statement, right? So this would be infinitely many solutions. All right, so before I switch this screen, any questions on question 1 or 2? All good? Okay, question 3. Do we want to see 3? Yes? Okay. 3 says, for his long-distance phone service, Greg pays $5 monthly fee plus 9 cents per minute. Last month, Greg's long-distance bill was $19.04. How many minutes was Greg billed?
Oh, wait,
So,
sorry. I thought that went with number 4. I'm
oh,
sorry.
okay, that's all right. Does anybody want to see number 3? Okay, so 4 is the one that you were wanting, Karen. Is that right? Okay, so we'll move on to 4 then. 4 is an equation where we're trying to solve for y, but it won't just have a number when we're done. We have other letters still involved. The process is very similar still. I need to get y alone. There are 2 different things you could do, okay? Most of you probably distributed first. So I'll do that option first and show you what it looks like. So this is yh minus h equals c. And then if the goal is to get y alone, what would I move first? What was it? It's the second h, actually. You got to start further away and get rid of things, and you get closer and closer. So the first thing I would do is add the h, that's the second h. So I'd have yh equals c plus h. And then how would I move the h that's attached to the y now? You divide, because it is being multiplied. So one answer would look like this, c plus h over h. Let me show you a second option just in case you like it any better. It happens to be true that the h over here is being multiplied by the y minus 1, right? So if you wanted to, you could start by dividing by h, and that would eliminate it from the left-hand side altogether. So I'd end up with y minus 1 equals c over h. And then what would I do? Yeah, I'd add my 1. Now, the reality is that although they look different, this is the same answer. If I were to get that 1 written as the fraction h over h, I could combine them together and it would look like the other solution. So this is just 2 versions of the same thing. Any questions on that one? All right. Wow, I have a lot of writing on my next page. How about question 5? Yeses or nos? Yes. Okay. So on question 5, let's see, it says, a total of 616 tickets were sold to the school play. They were either adult tickets or student tickets. There were 66 more student tickets sold than adult tickets. How many adult tickets were sold? When we did this problem, back in the day, so to speak, we did not do systems of equations. So I'm going to show it to you in the way that we did it at that time, but I'm also going to show you how you could do it now that we've learned a little bit more in terms of algebraic techniques, okay? So when we did this before, we started by recognizing that there's 2 things we don't know. We don't know the number of student tickets, and we didn't know the number of adult tickets. And they tell us that there's a relationship between them, and that relationship is that there are 66 more student tickets than adult tickets. So if adult tickets are A, then the student tickets would be A plus 66. Does that make sense for everybody? Okay, so that's how we did it then. And then it says that there was a total of 616 tickets sold. So what we would need to do is need to add these 2 together, and then they'll equal 616. So I have A plus 66 plus A equals 616. So this is 2A plus 66 equals 616. I subtract my 66. So what is 616 minus 66? I think it's 550. Yeah? And then we would divide by our 2. So what would A equal? What is 550 divided by 2? 275. And then this 275 is what? What did I find? Yeah, I found 275 adult tickets. And that's actually what was asked. If it asked for student tickets, what would I do next? Yeah, I would add 66 to that. Okay, so this is how we did the problem then, and it works perfectly fine. And if you see this problem again or something like it, you could certainly do this. There's nothing wrong with this method. There is another method that we have talked about now, though. And in that method, what we've done, and we have said that we have like adult tickets and student tickets. I'll use A and S. And I won't write out my stuff over here like I did before just for sake of quickness, but this is S and this is A. So S is the number of student tickets and A is the number of adult tickets. And what you have is let me do it that way, A plus S is equal to 616, right? 2 unknown things added together. And then you have a relationship that says S is equal to A plus 66. Student tickets is 66 more than the adult tickets. And then we used substitution. But notice very quickly, if you use substitution and you plug this in here, what happens? It's the exact same equation we already solved before, right? So it's just to set up kind of a difference. How do you view this setting it up? And either of those methods would work. How about number 6? Yes. 6 is one of our distance, rate, time problems. It says a car passes a landmark on the highway traveling at a constant rate of 40 kilometers per hour. 2 hours later, a second car passes the same landmark, traveling in the same direction at 65 kilometers per hour. How much time after the second car passes the landmark will it overtake the first car? And it says don't round anything. So there's a lot going on in this problem. I think that the distance, rate, time problems, some of them are more straightforward than others, number one. And some of them are really difficult. They have a lot going on, and this one's one that seems like it's got a lot going on. A couple things that might help is to recognize that there are two different cars and they're doing different things, right? So if I kind of identify the cars as doing separate things, we already know that they've got distance equals rate times time, but they have different characteristics to them. For example, their speed. Their speed or their rate is different. What is the rate of the first car that's described? It's 40. And what is the rate of the second car? 65. So I think all of us would recognize that eventually, if they keep going at these rates in the same direction, the second car is in fact going to speed up and catch it, right? Like, not speed up, but he's going to catch the first car. He's going to pass him. The second thing that's happening is that it says that they are traveling at different lengths of time. It tells you the first car passes the landmark, and then 2 hours later, the second car passes the landmark, which means they didn't leave at the same time. They haven't traveled at the same amount of time, right? So if the first car's traveled t, and we don't know how much it is, but if he's traveled t, how long has the second car traveled? Yeah, t minus 2. And what can you tell me about the distances at the point when the cars meet? What will be true about the distances that they've traveled? They'd be the same. That's important because they wouldn't have to be. Like, think about our train problems. When our trains are traveling opposite directions or something, they don't have to have the same distances they've traveled, right? So that's a unique characteristic of this particular situation. These distances are the same. And the reason that that matters here is because if you take a look, we have two equations and two unknowns, much like we've been working with recently, right? Because the distances are the same, these also have to be equal. The fact is, these are equal, so the right-hand sides are equal, and I can set them equal to one another to solve. So I know that 40t is equal to 65 times t minus 2. And at this point, the problem is no longer difficult. You've seen lots of problems with single one variable in the problem kind of thing going on, and we've worked through them many times. So I'm going to distribute my 65. So I have 65t minus 130. I need my t's on the same side, so I'll move them to the left since that's all that's on the left is the value with t in it. So it's negative 25 t on the left and negative 130 on the right. What do you get for t here? 5.2, and that's not rounded, that's the exact answer, right? Yeah. All right, so let's answer the question. Now we've solved for the variable t. It's really our only variable. We could solve for d if we were asked about d, but let's look at what the question asks before we decide if we need to. The question says, how much time after the second car passes the landmark will it overtake the first car? So what is 5.2 answering in this problem? Is it answering the question that's asked or something different? The total time that... Nope, you're close though. Nope. It's the time for car 1. Yeah. Look back up on our equations. When we identified the variable t, t was the time for the first car. But it's related to the time for the second car, obviously, right? And if we want to know how long it takes for him to to catch up, that's the time the second car has been driving. So yes, the first car drove 5.2 and it's in hours, right? But it's been 3.2 hours to catch up, to overtake, to whatever language you want to use, but this would be our answer to the actual question they posed.
And how do you get there? What did you?
I used this.
So you just plugged it back in?
I didn't plug it in. I mean, exactly. I just recognized that that's the time. It's 2 hours less for the second car. The reason I'm saying it that way is that I don't want you to think that I'm trying to plug it in to find D, because that's not what I'm doing. So I'm evaluating the time component of it, and so that's the relationship. Yeah. Yep. Any other questions on this one? Okay. I'm going to guess when you guys go back and you look at your other questions from your exam that you actually took, the exam 1 or exam 2 version, whichever version you took, that we might redo another couple of these kind of problems because the distance rate problems are harder. All right, how about number 7? Does anybody want to see number 7? Okay, how about number 8? Yes, A or B or both? Both, okay. So question 8, letter A, wants us to find 55, it says 55% of 60 is what number? All right, so when we did these problems, and this is not the only way to do it, so if you have a method you like better, that's fabulous, but at this point I'd want to consistently do the same thing. We did proportions, and I think proportions are really nice for doing these problems. So when we set up our proportions, they always looked like this. Okay, it's fraction equal to fraction, or a ratio equal to ratio, and one of the ratios is out of 100. The ratio out of 100 represents the percentage side of this equation. So we already know that the 55 goes here because 55 is a percent. So our only question really is the 60 on top or is it on bottom, and which other place will I put the x variable? So it says 55% of 60. So it's a percentage of the 60, and 60 would then be the whole. So 60 would go on bottom. And the piece I don't know, I'll use x, would go on top. So cross multiplication, I end up with 100x equals 3,300. Cool. And then if I divide by 100, what would x be? 33. So 33 is 55% of, what was our number, 60. Right? When I was younger, my grandfather and my father had a joint business. They were roofers. And for a really long time, because my grandfather started the business, he had the clientele and everything, they had a ratio on how their income got split. So the money would come in, and it was a 40-60 ratio. And so my dad would get 40%, my grandfather would get 60%. That's what's going on here. There's a percentage. So if you had a, what did we have, 55% ratio that you were supposed to get of that $60, you would get $33. That's what's going on. All right, part B says 52 is 65% of what number? So again, we've got a proportion we can set up with 100%. Somebody tell me where another number that's present here goes. 52 is on top, which top? That's the left or the right? On the first one, okay. And right. So the 65 is a percentage, so it goes on the side with the 100%. 52 is actually the portion, like in my scenario, if we were talking about it, that my father or my grandfather would have received out of something, okay? So, and that something is what we don't know. How much was the total amount of the value we were starting with? So if I cross multiply, I have 65x equals 5,200. And if I divide by 65, what is x? X is 80, yeah. Any questions on that one? All right, how about 9? Yes? No? Change your mind. Okay, 10? 10? 10 says a TV has a listed price of $784.98 before tax. If the sales tax rate is 9.75%, find the total cost of the TV with sales tax included. And again, you don't have to do this with proportions, but I'm going to. So we have 700. It was 748. I didn't do that right. 784.98. And then we have a tax rate that is 9.75%. All right, so what we need to figure out is how much tax there is on this particular product. So I can set up a proportion, same as the last problems, out of 100. And then my percentage is the 975. 9.75 would go on top of the 100. So where is the 784.98 going to go? It actually goes on the bottom. The 784 is the total price. It's representing 100% of the cost. So it's like parallel to, if you will, or on the same line as the 100. The tax is corresponding to the tax rate along the top of the equations. And that's what I don't know, so that's going to be my x. If I cross multiply, this would be 100x equals, I have written down 7,653.555. And then we'll divide by 100. When we divide by 100 here, we do need to round because we are dealing with money. So I need to round this to 2 decimal places, and I would get 76.54. That's my tax. Is that what it asked me to find? No, I need it, but it's not where I'm not done, right? What did it ask for? Yeah, the total price with tax. So how would I find the total price with tax? Right, I'd add the 76.54 to the original amount, which was 784.98. And my total price for my TV is now $861.52. You got to remember tax, right? Got to remember the tax on the TV. All right, any questions on 10? Okay, how about 11? $12. Feeling like we're making huge progress because these are like one-page questions with the graphs on. How about 13? We're all good? 14? 14, okay. 14 wants us to consider the line negative 6x minus 3y equals 3. And the first question on part A wants us to find a perpendicular line through 8, negative 5. All right, so what do you remember about perpendicular lines? What's important to remember? Okay, they have opposite slopes. Can you clarify what you mean by opposite? Negative, so if one's positive, the other's negative, what else?
So, like, slope is next to the x, so it has to be, like...
Okay, so the slope doesn't have an x in it, but what were you going to say, Megan?
Yeah, it's a fraction.
Yeah, it's a fraction, and what does it do? Reciprocals. Okay, guys remember the word reciprocal? Yeah, so we flip fractions. So piece it all together and we're good to go. So the slopes of perpendicular lines are negative reciprocals. So if one of the slopes is 2/3, then the other one would be negative 3/2. We do a negation and we flip it. Now, the way that this is currently written, I can't sort of see the slope very well, right? What would I need to do to change this so I can see what the slope is easier? Yeah, I can move things around. I need to solve for y. Everybody good with that? So if I take this equation and I solve for y, that would be my first step. So the first thing that I would do probably is to add the 6x to the other side. Not the order you have to do it in, but that's what I would do. So you'd end up with the negative 3y still equals 6x plus 3. And then what would you do? Yeah, you divide by negative 3, and I'll just write it as division on all the pieces. So this would be y equals negative 2x minus 1. So what is the slope for my line here? Okay, the slope for my original line was what? That line that I just wrote down, what was its slope? It was negative 2. So the slope for the line I'm creating, like you just said, the slope of the perpendicular line would be 1/2. Okay, so if you take 2 and you flip it, 2 over 1 becomes 1 over 2. Because it was negative, now it's positive. So now I have a slope and a point. Yeah? And the way that we talked about that in class, and again, this is not the only way, but it is the way we talked about it at least the most in class, is that a standard form of a line is y equal mx plus b. And so if you look at this, you have an x and a y. It's the ordered pair you were given. And you have an m that we found, and we should be able to figure out what b is. So the point that I was given was that y is equal to negative 5. The slope that I found is 1/2. The x value I was given is 8, and I have plus b, the only thing I don't know. So what's 1/2 of 8? 4. And if I subtract the 4 to the other side, what will my b value equal? Negative 9. So my equation is y equals m, which was the 1/2 I found, x minus 9. That was point A, or part A. Part B wants to have a parallel line. What do you know about parallel lines?
They have the same slope as the original one.
Right, same slope as the original line. Hang on. Okay, so if I'm working with the same slope as the original line, I know that my slope is going to be negative 2. And it tells me to actually, for part B, to use the same y, or the same ordered pair. We're going through the same point. So I'm going to have y equal mx plus b. The y value is still is negative 5. My slope is what? Negative 2. And my x value is 8. All right, so I have negative 5. Negative 2 times 8 would be negative 16. And if I add 16 to negative 5, what do I get? Yeah, 11. So my equation for this one is y equals the same m value, negative 2, and then plus 11. Any questions on that? All right. How about 15? $16. 17. 17 is a very challenging problem on this test. 17 says, the credit remaining on a phone card in dollars is a linear function of the total calling time it made with the card in minutes. The remaining credit after 33 minutes of calls is $25.38. The remaining credit after 57 minutes of calls is $22.02. What is the remaining credit after 80 minutes of calls? So the first thing to recognize is that there's a relationship between the minutes that are there and the time that's spent. I mean, the minutes that are there and the money that's left. So if you want to think about creating sort of a table of what's going on, it might help to think about it that way. So this is the time. So on the first one we had 33 minutes. And on the second one we have 57 minutes. And on the last one, eventually, we want to know what happens when there's 80 minutes. And then there's the money. So on the first one, it's 25.38. On the second one, it's 22.02. And we're trying to figure out what happens when it's 80. This is what's going on. So this should make sense that as you spend more time on the phone, the money on the phone comes off of it, right? This works for a calling card. If you have ever had the experience of being international, most phone plans in Ethiopia are done just like that. You go and you buy minutes on a card and you load the card onto your phone. There's no cell phone plans like we have here. That's a super foreign concept to my children when they got there, this idea. But you just buy a little calling card thing and you add minutes to your card, okay? This is very common, just not so much in our everyday lives with the way we do our plans. But look at this. I mean, there's a certain number of minutes that passed between the 33 and the 57, and then there's a certain number of money that went away, right? And we should be able to calculate both of those quantities and figure out how much every minute is costing us. Does that make sense? And the calculation for that is actually a calculation of slope. It's the money divided by the time. How much money is going away? How quickly is the money going away based on how many minutes we're using? And if you take a look, the money goes from 22, if we look at the most recent time, is 22.02 minus the 25.38. And then the time is 57 minutes minus 33 minutes. So how much difference is there in the dollar amount? What do we have there when we subtract? What's the numerator? Yep, negative 3.36, and the denominator is 24. So what happens when you take negative 336 divided by 24? Okay, so in context, what does that tell you? Yeah, the phone calls are 14 cents a minute. Do you guys see that? That's what that's telling you. Every minute on the phone is costing 14 cents. Okay, so what we want to know, though, is what happens when we have spent 80 minutes on the phone. But we want to know how much is left. I mean, we can figure out how much we've spent, right? If I just multiply this 0.14 times 80, that'll tell me how much it was spent. But it doesn't mean that I know how much money the phone card started out at, right? That was not actually given information. So how am I going to figure out how much money started on the phone card? Any idea? Your best option would be to ask the person that bought the card. But unfortunately, we don't have that at our disposal. So we're going to use what we did on the last problem. And what we're looking for is the B value, the initial amount on the card. And I know two different XY ordered pairs, and I can choose either one of them to let be X and Y. X for time, Y for money. So I think I'll just use the first one. Y is 25.38. M, I just found, was negative 0.14. And X in this case would be 33. All right, so what is my 14 minutes times my 33, or 14 cents a minute times my 33? What do I have over here? Negative 4.62. Good. On the left, I have 25.38. So what would I do? Yeah, I'd add the 4.62. And it's 30. Initially, there was $30 on the phone card. So my equation is y equals negative 0.14x plus 30. And how could I find out how much it costs for my 80-minute phone call? Yeah, or how much is left on my thing. Right. I can plug in 80. So if I plug in 80 times 14, that's going to tell me how much the phone call cost me. And then if I were to take that away, right, from the 30, that will tell me how much money's left on my card. So what do you guys get? $18.80. Number 18 is super similar, but I don't mind doing it if you want to see it. So do you want to see 18? Yep, okay. So let's take a look at 18, and we'll think about it from the very same perspective, all the way back to starting by looking at a table of what's going on. It says the monthly cost in dollars of water use is a linear function of the amount of water used in hundreds of cubic feet, HCFs. The cost for using 1,800 cubic feet is $38.86. The cost for using 3,100 cubic feet is $60.31. What is the cost of using 2,900 cubic feet of water? Okay, so the 100 cubic feet of water is directly related to the money it costs, right? It says if I use 1,800 cubic feet, it costs me $38.86. My kids like to think that water is free. Do you think that water is free? We think of it like that, don't we? But you know somebody paid for that water, right? Your parents probably. To bring it into your house, they paid the city for it, like this. And then if you use 3,100 cubic feet, it's $60.31. So any guesses as to why most people's water bills are higher in the summer based on this? Sprinklers, that's right. It's usually sprinklers, or maybe they have a pool. Could be a possibility too. It's usually sprinklers. And the question is, what happens at 29? Now, I can tell you right now, 29 should be between what happened at 18 and 31, right? So whatever answer I get here in a minute, it better be between 38.86 and 60.31. Otherwise, we've made a mistake. There's a problem. So just sort of like estimation and eyeballing it. We need to look at that. But I need to figure out how much is 100 cubic foot, right? What is the ratio? What are they charging you? What's the rate of consumption? And I can do this just like it on the last one by finding the slope. So I have the 60.31 for 3,100 cubic feet. And then I have the 38.86 when I had 1,800 cubic feet. All right, so put some things in some calculators, figure out what your numerator and your denominator are for me, and let me know what you get for a dollar amount for 100 cubic feet.
I have a question. So how do you know what order to put? Like you had 60 minus 38.
So that's a good question. The reality is if you switched the order, you'd switch everything and you'd still make it work in the end. I mean, it wouldn't actually really affect the answer to the question. However, the way that it's usually done is that you have to think about what is affecting what. The money is not affecting the water usage. It's the water usage that's affecting your money. So the water usage is called the independent variable. It's the part that you have got like flexibility with. And then the other one that depends on it is the dependent variable, and you always list it second. So that's how I'm listing mine. But if you switched it, it's not going to change how you find your answer or what your answer would be at the end. Yeah. Alrighty then, what do we get for the ratio here? What do we get?
21.45.
On top, okay, you guys are giving me the two numbers, that's fine. 21.45 on top, and what was on bottom? 13, great. And then what do we get for the answer from that? Fabulous, 1.65. So my slope is 1.65. But I don't know what it just simply costs to have the services run to my home. So did you know that if you leave the house vacant and no water is running, there's probably still going to be a water bill? There's a base rate that they charge you when they do something like that for the very fact that you have a home and you're asking them to be available to give you water should you want it. That's the way it works. So we have to figure out what that value is to start with. So y equal mx plus b, that would be the b value I'm looking for. So y in this case, I'll just use the first one again like I did last time. Here's x, here's y, just alphabetically, and then I have 3886. M is 1.65, and x is 18. All right, 1.65 times 18, I'm just going to let you know it's 29.7. And what is 3886 minus 29.7? 9.16. So just because you have water piped to your home, whether you use it or not, you're paying $9.16. And your equation then, generally speaking, would be y equals 1.65x plus 916. And we want to know what happens when we use 2,900 cubic feet. So we'll plug that in. So what happens when I have those numbers evaluated? 57.01. Is that a reasonable answer based on my other values? Yeah, that's reasonable. Makes sense. Should be between the values, and we have 1 decimal or 2 decimals of accuracy. Okay, any questions about that one before we move on? Okay, how about 19? 20? Yes? Okay, let's look at 20. 20 is finding complex solutions. We have the equation 7x squared plus 3x plus 3 equals 0. So there are 3 ways to find out when something equals 0. All right, so one of them would be factoring. And when it works, it's the easiest. It just is. It's the fastest, quickest, it's great. They've kind of given you a clue that it's probably not going to factor here because they told you that the solutions are going to be complex. All right, so that's probably not going to work. Your second possibility is that you could use the quadratic formula. That's my preference, is to go with that one second. That's the one I'm going to show you. The third option, and it really is an option, is that you could do completing the square. So these are the 3 options, at least, that we discussed in class on solving a quadratic equation. Quadratic formula is kind of nice. You do have to memorize it, right? It would be x equals negative b plus or minus radical b squared minus 4ac all over 2a, like that. A, b, and c are directly identified by, by the coefficients in your equation. The x squared term is the a coefficient. The coefficient is a. The linear term x is a coefficient of b, and then the constant term at the end has a coefficient of c. Okay? So on this one, the b value is 3, so this is negative 3 plus or minus 3 squared minus 4. A is 7, and c is also 3. And it would be divided by 2 times a, which is 7. Everything has to be cleaned up underneath the radical before we can do any combining or simplifying. So I'll square first. That would be 9. So I have negative 3 plus or minus the square root of 9. And then what is 4 times 7 times 3? 84. So then that's minus an 84 over, and I could multiply the 2 and the 7 if you'd like. That's 14. So what is 9 minus 84? Yeah, it's negative 75. And in particular, it's negative, right? So the fact that there's a negative underneath the radical is okay. We can't graph something like that. We don't have a real number that's coming out of this. It's complex, but it's okay. It's just not real in the sense that it's a real number. It's a complex number. So when we look at the 75, we can still do the factoring with it just like we would do if it were positive. The I, the negative simply means that we're going to have an I that's going to come out of that. So in a minute here, when I write down the next piece, I'm going to have plus or minus an I right here. And then I'll have, whatever happens with my square root. So let's take a look at 75. If I were to factor 75, how will 75 factor? 5 and 15. All right. And then 5's prime, but how will 15 factor? 5 and 3. And if you take a look here, what you notice is the 5 duplicates, right? There's 2 5s. Square roots mean that if I have 2 of the same item, I can bring one of them out. So I'm going to bring out a 5. I'm going to write it in front of my I. And the 3 is still underneath the radical. And this is all over 14. On this one, I'm actually done. What I have to know to be done is I have to look at these values and make sure that they don't have anything that divides all of them. Like if they were all even, I'd divide them all by 2, and then I would, see if there's anything else they could just simplify by. These don't have anything. So this answer, like this, is actually our final answer to the question. There are 2 complex numbers here. Why are there 2? I mean, I just wrote down one thing. There's a plus or a minus. I could separate them out and write the plus and the minus separately. That's where there's 2 answers. How about 21? Yes. That one was a pretty quick yes. Okay, 21 says a ball is thrown from an initial height of 2 feet with an upward velocity, that means speed, of 24 feet per second. The ball's height h in feet after 2 seconds is given by the following equation. So I have h equals 2 plus 24t minus 16t squared. We didn't talk very much about these kinds of equations, where they come from, but you can see the 2, right? The 2 is the initial height of the ball. The 24, that's the speed of the ball. Any idea what the negative 16 is? Does anybody know from any other classes you've had?
Is that the gravity thing?
Yeah, it's the deceleration for gravity. Gravity forces the ball to come back down, right? That's actually coming from gravity. So that's where the equation's coming from. It wants us to find all values of t for which the height's 6. So clearly when you throw it up, if it gets to 6, it will not only get to a height of 6 and keep going, but if that's what happens, it would then come back down. So there's going to be 2 locations, at least potentially 2 locations, where it's going to get to a height of 6 feet. Okay? So what we want is this h to be 6. And we expect, at least we kind of expect 2 answers from it. So I have a quadratic equation, much like the last problem, except that it's in context, of course. And I need it all on the same side. It's not on the same side yet. So I would probably be tempted to go ahead and just move everything to the left-hand side. So this would be positive 16t squared. I would have negative 24t. And then if I subtract my 2, I would have plus 4 equals 0. Kind of like my t squared in this case to have a positive coefficient. It's kind of nice. there's a lot of things you could do. You could just go from a quadratic formula right now. But when I look at this, I think, number one, those numbers are kind of big. But number two, they all are even, right? So if you notice that they all have something in common and they're set equal to 0, it's going to be easier to work the problem later if we can take out what they have in common as a factor. So what is the biggest number that divides all three of these coefficients? It's actually the number 4. So if I divide everything by 4, and I'm allowed to do that, there's nothing wrong with that, I will have numbers that will be easier to work with. So this is 4t squared minus 6t plus 1. It could factor, but it doesn't. We could do the completing the square, but that's usually more work. Quadratic formula is the nicest way to do this problem. So t equals negative b, so I have opposite of negative 6, so it's a positive 6, plus or minus the square root of b squared, so it's negative 6 squared, minus 4 times a, which is 4, and c, which is 1, all over 2 times a, which is 4. Okay, so like we said, it's a positive 6 at the beginning. What is 6 squared? Negative 6 squared. It's 36. And then what is 4 times 4 times 1? 16. So if I take 36 minus 16, what do I get? Do you get 20? Yeah? And an 8 in the denominator? Okay, so once we get to that point, just like on the last problem, the 20, we would like to see if it factors. So how will the 20 factor? 2 and 10, okay. And then 5 and 2. And in fact, again, the 2's duplicate. So I can rewrite this as 6 plus or minus, and I can pull out a 2. And I leave it as square root of 5 over 8. Am I done? Yeah, they are all divisible by 2. So I can divide each by 2, 3, 1, and 4. Notice I'm not worried about the square root part. It didn't have to be divisible by 2 because it is multiplied by the value on the outside already, okay? So my answer in like non-rounded form is 3 plus or minus square root 5 over 4. Here's the deal. This is a context question. And if somebody asks you, at what time does the ball reach 6 feet, you say 3 plus or minus square root 5 over 4 seconds, you're right. You're going in the I'm a nerd category, right? Like that's not really what they were exactly asking, right? I mean, it sort of was, but not really. We need decimal approximations for this for it to make any sense. Absolutely. So grab your calculator and find out what is 3 plus square root 5. Hit enter and then divide by 4. And do the same thing with the minus. And it says nearest hundredth for our answer, so we would use 2 decimal places. What was it? 1.31. Is that what you said? Uh-huh. And these are in seconds in the problem. What's the other one? 0.19. So at 1.31 seconds and at 0.19 seconds. Really fast. Really fast. Any questions on that one? Okay, how about 22? $23? $24? Ooh, this page must have been a good one. 25? Got absolute value starting there. 26? 27? I really want to see these perfect papers that you guys are looking at. Are they perfect? Were these just easy ones? They were? Okay, Michaela says they were easy. 28. It's all good? Or you want to see 28? You do want to see it, or is it good? You want to see it? Huh? Yes, you. Let's do 28. Sorry, I keep talking over you, Joan. I don't mean to. 28. 28 is 2 over v squared minus 10v plus 24 equals 1 over v minus 6 plus 3 over v minus 4. So the first thing that we would want to do is to factor the quadratic that's in the first denominator. And I'm just going to write it in a different color below for the moment. I've got v and v. What else do I have? Should both be subtraction because I need a positive at the end and a negative in the middle. 6 and 4, which is also very friendly. Why? Yeah, because they are the same on either side. So my suggestion has always been, let's eliminate fractions when we can do so. So that's what I would suggest. I would suggest that we take what we have, which looks like this, whoops, and that we multiply each of our fractions by v minus 6, v minus 4. So then I've got 1 over v minus 6 times v minus 6, v minus 4. Plus 3 over v minus 4 times v minus 6, v minus 4. And the reason we can do that is because we're doing it to all three terms. And the reason it's helpful is because I'm multiplied by every single piece of every single denominator by doing that. Now on the left-hand side, what I'm multiplying by is exactly the denominator, so those two are in fact like the value 1. I'm multiplying and dividing by the same thing, so I'm left with the number 2. On the right, part of what I'm multiplying by is the denominator. The other part is still there, so I have the numerator times the other portion I'm multiplying by, which is v minus 4. And then the same sort of thing is happening on the second one. The v minus 4 is duplicated, but not the v minus 6. So I still have left the 3 from the numerator and the v minus 6 that I'm multiplying by. And the problem is, wow, like night and day difference in terms of easier at that point, right? It really is. Now I have v minus 4, and we'll distribute my 3, plus 3v minus 18. That would make 4v minus 22. I can add my 22. So this is 4v equals 24. And if I divide by 4, what is v? 6. Now here's the deal. We started out the problem with fractions, and fractions can't have zeros in denominators, so we have to make sure that whatever answer we get at the end did not inadvertently create 0 in a denominator. And this one did, right? There are two places where I have zeros in denominator. The original piece right here and the original piece right here. So I only found one solution, and the solution I found doesn't work. So what does that mean? Yeah, it means there's no solution. Because we know that v cannot equal 6, because it would make a 0 in the denominator. Is that okay? Okay, how about 29? Yes. And I think that's where we're going to have to end, and then we can talk about 30, 31, 32 if you want to next time. We'll just start there. But let's look at 29 before we close up shop today. All right, so 29 is 6 minus 5 over w plus 1 equals, I'm going to put the negative with the 6 on top, negative 6 over w minus 3. Okay, so the same goal as the last problem. We want to multiply by the denominators. The denominators just don't happen to match this time. So I've got 3 fractions. This is really like 6 over 1, right? So I have 6 times w plus 1. Yeah, that's fine. And what do I have? W minus 3. And then I have minus 5 over w plus 1 times w plus 1, w minus 3. equals negative 6 over w minus 3 times w plus 1 times w minus 3. Okay, so in the middle, the w plus 1s will cancel, and on the right, the w minus 3s will cancel. The very far left, there's no canceling because there's no denominator. So I simply need to multiply that out. And if I do, I'm going to have w squared. On the inside, I have positive 1w, and on the outside, I have negative 3w. Positive 1 and negative 3 is negative 2. And then the last digits multiply to give me negative 3. And then we distribute through on this one a negative 5. So I have negative 5 times w, so negative 5w. And negative 5 times negative 3, so positive 15. And on the right, I'm distributing my negative 6 through. So I have negative 6w minus 6. Now, this one did not clean up quite as nice or quite as quick, but it's not as bad as it might have been otherwise. I have 6w squared minus 12w minus 18 minus 5w plus 15 equals negative 6w minus 6. So let's combine like terms. I have 6w squared, negative 17w, and negative 3 on the left, and then negative 6w minus 6 on the right. We'll move them to the same side. So plus 6w and plus 6. So I have 6w squared minus 11w plus 3 equals 0. This actually factors. It's not a very pretty one. Like, you don't probably just look at it and go, oh, I bet that factors. I mean, because it's harder because I got the 6 at the beginning. Through trial and error, it does in fact factor. If you don't want to use trial and error, you can use quadratic formula to do it too. It's 3w minus 1 and 2w minus 3. That's what it ends up being. And if you set each part equal to 0, the first one gives you 1/3, and 2w minus 3 equal to 0 gives you 3/2, neither of which are problems with the denominators that we have. So we have 2 solutions on this one to our problem.